Alright, guys and gals, today we're going to be looking at transformations, linear transformations of exponentials. And what we will focus on is how these linear transformations affect the properties of our exponential functions. So let's say I have our linear function f of x is equals to 2 raised to the x plus 4. There are two things that we need to do and understand right here. First things first, the 2 right here is greater than 1, so the base is larger than 1, and so that this means that this is an increasing exponential function. Remember, increasing exponential functions and decreasing exponential functions basically have the same properties. The difference is, do I have exponential growth or exponential decay? Second thing I need to do is identify the transformation. Well, this right here is a shift up 4 units. So my base exponential function 2 to the x right here goes through 1 right here is a graph that looks like this. It has a horizontal asymptote along the x-axis, which is kind of hard to draw, that's why I'm scratching it in there. And if I take this graph and I raise it or I shift it up 4 units, I will get a new graph that looks exactly the same, but is now going to be 4 units higher. Well, if it's 4 units higher, what's the domain? The domain is going to be unchanged, negative infinity to positive infinity. Well, what's about the range? The range used to be 0 to infinity, but because I have shifted the graph, the range will shift. The range will actually increase by 5. The graph went up by 5. Going up by 5 changes the y-value. So my new range is going to be 5, infinity, because I went up by 5. So when you have a shift up, let's say I go shift up b units, the range is going to be 0 plus b, infinity, because I am going up by b units. And so in this case by here, 0 plus 5 is 5. My x-intercept, my y-intercept used to be at 1, 0. Not 0, 1, that's backwards. But now I am shifting up. My new intercept right here is going to be 0, 6. Because I'm going up by 6 units. And so therefore I need to fix this. This right here is going to be 0, shifting up 4 units. So therefore this, I'm thinking from the other one, that should be a 4 right here. And then this goes up, and so this is the 5 right here. So if you, again, shift up b units, you're going to be 0, 1 plus the size of the shift. This graph is increasing still. Increasing doesn't change when I shift the graph up or down. And the horizontal asymptote, your HA, it used to be y equals 0, but I'm shifting the graph up, so the horizontal asymptote is now right here, higher. So my horizontal asymptote, if you think about it, if it was at 0 and I go up 4 units, 1, 2, 3, 4, the horizontal asymptote will now be at 4. And so my HA is always going to be y is equals to your 0 plus b. So when you shift the graph up or down, 3 of the 5 properties change. Those 3 properties are the range, the y-intercept, and the horizontal asymptote. And those come from the fact that all of these are y's. All of these are horizontally based. And therefore, if I go up or down, these will change. Notice that the other two don't change when I shift the graph up or down. So, what's about shifting the graph left or right? So let's say I have f of x is equals to 1/4 raised to the x minus 3 right here. This right here, first and foremost, the base is 1/4, and unlike this base right here, the base is a proper fraction. It's between 0 and 1, and that means I have exponential decay, a decreasing graph. And then this x plus 3 right here is a shift. Remember, you have to do the opposite of what you see. So it's going to be a shift to right. 3 units. And because I am shifting right 3 units, first and foremost, my graph of my function is a decaying graph, so it'll go down. It'll still go through the point right here of 0, 1. But now I'm pushing the graph over 4 units. So I'm pushing the graph over 4 units. So in doing so, I get a graph that looks exactly the same as my original graph, but it's just 4 units over. So this right here is my shifted graph. Well, what are my properties? Well, my domain is still negative infinity to positive infinity, so my domain did not change. My range, notice the graph right here is still getting close to the x-axis, so my range actually does not change. It stays at 0 to infinity. My graph is still increasing. So again, that doesn't change. My y-intercept, my y-intercept is way up here now. So therefore, my y-intercept does change. Well, to find the y-intercept, I guess I have to plug in x equals 0. And so then this is going to be 1/4 raised to the 0 minus 3. Well, what's 0 minus 3? 0 minus 3 is just a negative 3. Remember, the minus sign means a reciprocal. And so this is just 4 raised to the 3rd power. 4 times 4 is 16. 16 times 4 is 64. So this new point up here is 0, 64. So your y-intercept 0, 64. Right here you have to plug in 0. The horizontal asymptotes, your HA, will remain at y equals 0. If I take a horizontal asymptote, which is the x-axis right here, and I slide it over 4 units to the right, I will get the same line. And so therefore the horizontal asymptote does not change. And so that takes us to the basic rule. When I am shifting left or right, only the y-intercept changes of my 4 properties. Of course the graph changes, but of the 5 properties, only 1 changes. Contrast that with the shifting up and down when you have 3 of the properties changing. Interesting, right? Yeah, I know. Stuff is very interesting. Well, that's transforming up and down. The other transformations we will look at today are your reflections. So let's say I have f of x is equals to negative 3 raised to the x power. Again, my base is greater than 1. So that means I have an increasing function. Exponential growth. The minus sign in front of the graph right here means a reflection in the x-axis. This would basically make the graph upside down. So, to my graphing, utility. I have an increasing function, so my increasing function will look something like this. And I know that this point right here is 0, 1. Now if I reflect this over the x-axis, I will get a graph that is upside down. And the graph right here will look like this. This point down here clearly is 0, negative 1. Clearly, yes? So, what are my properties? Well, my domain, still negative infinity to positive infinity. Hopefully by now you've noticed that the domain never changes. The domain for every exponential function of any type will always be all real numbers. The range, on the other hand, has now changed. This graph is going down to negative infinity, and it is going to have a ceiling of 0 because of the horizontal asymptote. And so my range is now only negative values. Think about it. If I plug an equation, a number into x right here, I get an answer, and then I'm going to make it negative. My answer is always going to be negative. And so therefore this right here is a negative function. By the way, it's important to note that my base is not negative. Because of PEMDAS, I actually have to work this out first and then multiply by the negative. PEMDAS says I must do the power first. And so my base is not negative. I am just multiplying by a negative after I work the equation out. Okay, so my graph is now decreasing. Used to be going up. Now I'm going down, down, down. So therefore it's decreasing. My Y-intercept is now flipped sign, so it's going to be 0, negative 1. When you reflect the graph, the signs on the intercept change. And the horizontal asymptote, your HA, is still at 0. So when you reflect the graph in the x-axis, what we note is that the range and the increasing, decreasing, and the y-intercept change. Notice, again, 3 out of the 5 have changed when I reflect over the x-axis. So I'm pretty sure you're thinking, well, if I reflect over the y-axis, then, well, let's find out what happens when we reflect over the y-axis. So let's say I have f of x is equals to 1/3 raised to the negative x to reflect over the axis. I need to make the x negative right here. So again, my base is 1/3. Base is between 0 and 1. And so I have a graph that's decreasing. The minus sign on the x right here means I have a reflection over the y-axis. And with that reflection over the y-axis, I can go ahead and graph my function. So, again, going through 0, 1, all these graphs go through 0, 1. A decreasing graph, eating that cake, but leaving some for tomorrow, you know. Good steward of my cake. If I take that right here and I reflect it over the y-axis, what I will get is that this piece right here will go to the other side, and so it will be over here. And then this piece right here will go to the other side, and so we'll get this right here. And so this graph right here will have a domain of all real numbers. It will have a range of 0 to infinity. It will be increasing. It will have a y-intercept of 0, 1, and it will have a range, a horizontal asymptote, HA, of y equals 0. When I reflect the graph over the y-axis, only one of the four properties change, the graph switches from decreasing to increasing. Interesting, right? Well, if you think about it for a second, what does a minus sign mean? A minus sign means a reciprocal. Well, what's the reciprocal of 1/3? The reciprocal of 1/3 is simply 3 to the x. 3 to the x is our basic exponential function. And so that minus sign right there simply switches the graph from increasing to decreasing. Okay, that's a basic overview of your properties of exponential functions. There is more to know about these, but we will be switching gears right now, and we'll be looking at equations involving exponentials.